The world we live in is built on a comforting, intuitive logic. If you leave your keys on the kitchen counter, they will remain on the kitchen counter until a physical force moves them. If you scream in an empty canyon, it takes a predictable number of seconds for the echo to return. Cause and effect, here and there, before and after. But drop down to the scale of a billionth of a meter, and the universe stops playing by these rules. Down there, the universe is not a clockwork machine. It is a casino. This is the story of the night that reality's illusion broke for two physicists. Deep beneath the granite spine of the Swiss Alps, Dr. Elias Vance and his postdoc, Sarah Lynn, were exhausted. It was 3 a.m. The subterranean lab hummed with the aggressive drone of cryogenic cooling systems, and the air smelled faintly of ozone and stale coffee. They were playing a game of cosmic billiards, but their cue ball was a laser, and their table was a crystal of barium borate. When a high-energy laser hits this specific type of crystal, something beautiful happens. Occasionally, a single photon of light is split into 2 perfectly identical, lower-energy photons. In quantum mechanics, these 2 photons are not just siblings, they are entangled. "Align the beam splitter," Elias mumbled, rubbing his eyes beneath his safety goggles. "Let's see if the fibre is holding." Sarah tapped at her terminal. "Alignment green," sending Alice to the local detector, sending Bob to the mountain. In their nomenclature, the 2 photons were Alice and Bob. Alice stayed right there on the lab bench. Bob, however, was channeled into a fibre optic cable that snaked through 10 kilometres of solid rock to a receiving station in a deserted ski cabin atop the adjacent peak. Elias was trying to prove something that Albert Einstein had famously hated. Einstein called it spooky action at a distance. The theory of entanglement suggested that Alice and Bob were deeply, intrinsically linked. If you measured a property of Alice, say her spin or the direction she vibrates, she would instantly pick a direction, up or down. But the terrifying part of the math stated that the very instant you looked at Alice, Bob would instantaneously assume the opposite spin. Not a millisecond later. Not at the speed of light. Instantly. Einstein argued this was impossible, as nothing moves faster than light. He claimed the photons must be like a pair of gloves. If you open a box here and find a left glove, you instantly know the box 10 kilometers away holds a right glove. There is no spooky communication. They were already a left and a right glove from the moment they were packed. But quantum mechanics said something much stranger. It suggested that neither glove has a shape until you open the box. They exist as a blurry haze of both left and right. Only when you look at one does reality snap into focus, and the other instantly morphs to match. "First run of the night," Sarah said, hitting the execute key. The laser pulsed. Millions of Alice and Bob pairs were created, split and measured. The data began to scroll down the monitor. Whenever Alice was measured as spinning up locally, Bob was found to be spinning down on the mountain. When Alice was down, Bob was up. They were perfectly anti-correlated, every single time. "Okay, they're matching," Elias said, leaning closer to the screen. But Einstein could still be right. They could just be hidden gloves. We need to trick them. This was where the tension lay. To prove the universe was truly spooky, they had to change what they were measuring while the photons were already in flight. "Engage the randomizers," Elias ordered. At both ends of the 10-kilometer cable, highly advanced random number generators took over. While Alice and Bob were traveling at the speed of light, the detectors at either end rapidly switched the angle of measurement. It was the equivalent of asking Alice if she was spinning up or down, but asking Bob if he was spinning left or right. They switched the questions so fast, in a fraction of a nanosecond, that there was absolutely no time for a signal travelling at the speed of light to cross the 10 kilometres of rock and warn the other photon. If Alice and Bob were just pre-programmed gloves, the random switching would scramble the perfect correlation. The math of classical physics set a hard limit on how often the answers could match. The bell was ringing, the trap was sprung. "Data compiling," Sarah whispered. The hum of the cooling fans felt deafeningly loud. For a moment, the screen froze as the server passed the millions of data points, comparing the timestamps from the Deep Earth lab with the mountaintop cabin. Elias held his breath. He had done the math 1,000 times on a chalkboard, but seeing the universe actually obey the math was something altogether different. The screen blinked, and the final correlation coefficient appeared. It was 2.73. Elias let out a breath that sounded like a laugh. Sarah just stared. To classical physics and to Einstein's glove theory, the maximum possible value of that correlation was exactly 2.0. Anything above 2.0 meant the universe was not behaving locally. It meant the gloves were indeed changing shape in real time, across 10 kilometers of space, with 0 time delay. They had caught the universe in the act. "They know," Sarah said softly. "Alice knew what we asked Bob." "No," Elias corrected, leaning back in his chair, a profound sense of awe washing over his exhaustion. "It's stranger than that. Alice doesn't know what happened to Bob. Alice is Bob." The data on the screen wasn't just a number, it was a philosophical earthquake. For the rest of the night, they watched the numbers roll in, confirming it again and again. Distance was an illusion. The 10 kilometers of solid alpine granite separating the two photons meant absolutely nothing. In the mathematical space of quantum mechanics, Alice and Bob were not separated at all. They were a single, mathematically unified entity spread across physical space. As dawn broke over the Swiss Alps, painting the snowy peaks in hues of pink and gold, Elias and Sarah finally stepped out of the subterranean elevator into the crisp morning air. Elias looked up at the mountains, then down at his own hands. The story of entanglement isn't just about lasers and crystals. The Big Bang sprang from a singularity, a microscopic point where everything in the universe was crammed together, which means, at some fundamental level, every particle in Elias's body, every atom in the mountain rock, and every star in the morning sky had once been in intimate, tangled contact. The illusion of the everyday world had returned. He could drop his keys and they would fall. The echo would still take time to reach him. But underneath it all, beneath the comforting machinery of cause and effect, the universe was whispering a different story. It was whispering that nothing is truly separate, and that somewhere, across the vast, dark stretches of space, the ghosts of the quantum world were dancing together in perfect, instantaneous rhythm.